At UCLA, we're committed to tackling the greatest challenges of the 21st century. And the way that we do this is through developing the key technologies that'll enable solutions for these challenges.
I felt the need to go into engineering, and I felt the need to go into sustainability because I felt that that was the problem that I most attuned with, and the problem that I felt that I could solve in my lifetime.
I think it's really great to be a part of the energy of UCLA. Being here, you really feel like you're part of something, like you're working towards something bigger, and that you can actually elicit change.
In 2000, it cost $1 billion to sequence the human genome. Now you can sequence the genome for less than 1,000. And the question is, what we haven't known up till this time is, what specifically is it in the DNA that makes you at higher risk if your parents have a disease? And so what we will do is we take, for example, 10,000 people that have depression and 10,000 people that don't have depression, collect all their DNA, and then look for genetic variants that are more common in the individuals that have depression than the individuals that don't. We are analyzing massive amounts of data. We have petabytes and petabytes of data. I know with the kind of skills that I have and the perspective on my research that I have, my best way to contribute is through developing technologies that can really push these kind of studies forward.
In the last academic year, we produced nearly 20,000 tons of waste. That's a lot of waste. We're essentially a tiny city here at UCLA. And so we drive all of that waste over 100 miles to Victorville to be dumped into landfill. And that's unacceptable for me and for the UCLA community. And so we decided to essentially get facilities to bag up the trash and bring it down into Wilson Plaza and dump it down into the ground, and we would open those bags and sort that out and weigh the trash, compost, landfill, and recycling. As a student, I want to learn as much as I can. I want to give back to the university as much as I can. I want to see this campus go zero waste by 2020, and I want to be a part of that change. I want to lead that change here on campus.
The problem currently with brain implants is that they're far too stiff. So what we're trying to do is develop a material that inserting into the brain tissue is stiff, and then at body temperature will transition into a soft material that matches the stiffness of brain tissue. The first state is room temperature rigid. Stage 2, you heat it up past that transition point and it becomes stretchy. Step 3 would be running a current through it and creating a different shape than the original shape. Then you cool it down back under its transition temperature and it stays in that actuated state. And then you heat it back up and it goes back to its original shape. We're trying to, change the way that brain implants work. The biggest impact that I want to have on the world is to be able to make a difference in someone's life. And here at UCLA, I feel like I have achieved that. I think everyone here is trying to change something.